Relational database management systems support a set of properties known as ACID. This is a set of properties of database transactions intended to guarantee validity despite errors, power failures, and other mishaps. With atomicity, all changes to data are performed as if they are a single operation. That is, all of the changes are performed or none of them are. With consistency, data remains in a consistent state from start to finish, reinforcing data integrity. For isolation, the intermediate state of a transaction is not visible to other transactions, and as a result, transactions that run concurrently appear to be serialized. With durability, after the successful completion of a transaction, changes to data persist and are not undone even in the event of a system failure. With the benefit of simplicity, here the table structure is familiar to most users, particularly those who have worked with physical or software spreadsheets, check registers, or other tabular data. Since relational databases use tables of rows and columns, they display data more simply than some other database types, making them easier to use. Relational databases make it easy to scale data by simply adding rows, adding columns, or entire tables without changing the overall database structure. Another benefit of a relational database is reduced redundancy, also known as normalization. Data redundancy occurs when the same piece of data is stored in two or more separate places. Database normalization prevents redundancy and makes the best possible usage of storage. The proper use of foreign keys can minimize data redundancy and reduce the chance of destructive anomalies appearing. Data redundancy leads to data anomalies and corruption and should be avoided when creating a relational database consisting of several entities. With data integrity, relational databases work with structured data. Data integrity is considered one of the major benefits offered by a relational database. Strong data typing and validity checks ensure that data fall within acceptable ranges and required data are present. Referential integrity among tables prevents records from becoming incomplete or orphaned, and requires that every value in a foreign key column will be found in the primary key of the table from which it originated. Relational databases offer flexibility. SQL has a built-in language for creating tables called Data Definition Language, or DDL. DDL allows you to add new columns, add new tables, rename relations, and make other changes even while the database is running and while queries are in progress. It is easy to add, update, or delete tables or relationships and make other changes to data whenever you need, without changing the overall database structure or impacting existing applications. The relational database model is naturally scalable and extensible, providing a flexible structure to meet changing requirements and increasing amounts of data. The relational model permits changes to a database structure to be implemented easily without impacting the data or the rest of the database. In theory, there is no limit to the number of rows, columns, or tables. In reality, growth and change are limited by the relational database management system and physical computing hardware. Database security protects a database from unauthorized access, misuse, or damage. This benefits organizations by protecting their data from unauthorized access or modification, and individuals by protecting their personal information from theft or fraud. Since there are several tables in a relational database, certain tables can be made to be confidential. These tables can be protected with a username and password such that only authorized users will be able to access them. These users are only allowed to work on that specific set of tables. This is known as role-based security. Role-based security is easily implemented with a relational database management system unlike other databases. SQL stands for Structured Query Language, which is a programming language used to communicate with data stored in a relational database management system. SQL syntax is similar to the English language, which makes it relatively easy to read, write, and interpret. There is no need for large and complex code for data extraction. SQL does not require extensive coding and program writing knowledge. It is easy to maintain database systems without having to write a good amount of code. SQL is mostly made up of English statements, making it simple to learn and write SQL queries, while primary keywords like select, insert into, delete, and update can be used to carry out these operations. SQL is highly portable because it is employed in programs on PCs, servers, tablets, and independent laptops running operating systems such as Windows, Linux, Mac, and even some mobile phones. SQL works with an efficient speed. It can give users a rapid and effective means to retrieve, alter, or store data. SQL can quickly and efficiently retrieve a large volume of data records from a database. Compared to an unstructured database such as MongoDB, a relational database can characterize data in a structured manner. Operations like insertion, deletion, querying, manipulation, and calculations on data via analytical queries in a relational database can be accomplished in a matter of seconds. Use of table joins is considered a major benefit in a relational database management system. Joins combine rows from two or more tables where the tables are merged based on fields they have in common, known as primary and foreign keys. Table joins executes faster in comparison to using multiple queries to accomplish the same task. The ability to join data does help reduce data redundancy. I hope you found benefits of a relational database helpful. If you have, please click on the like button. And to receive any updates to this channel, click on the subscribe button. Thank you so much for watching.